All right, homework 29, we're doing the sum, difference, and product of two functions. So we're going to do s plus t of x, s times t of x, and s minus t of 4. We're going to put the 4 in for the x and evaluate the function. So if we're going to do s plus t, we're going to take our s function, which is 3x plus 6. We're going to add our t function, which is 4x. Since we're adding, I really don't need the parentheses, but I'll put them there for fun. And then all we're going to do is simplify that as much as we can. So we're just going to combine our like terms. 3x plus 4x would give me 7x plus 6. And that's going to be the first answer that we're going to put in. On the next one, we're taking s times t. So we're going to take the 3x plus 6 times our 4x. And so on this one, we end up using our distributive property. 3x times 4x is 12x to the second power, 12x squared. 6 times 4x, positive 24x. Those aren't like terms, I can't combine them. So that's really all I can do to solve that one. The third part, there's a couple different ways to do it. I usually like to do things in the same order I do all the rest of the stuff in, so I would probably just do the s minus t first. So if I take 3x plus 6 and I minus my 4x, I have to distribute my negative out. So 3x plus 6 minus 4x would give me negative x plus 6. Now what I'm going to do is I'm going to substitute the 4 in for my x's and evaluate my answer at x equals 4. So if I put a 4 in for my x, I get negative 4 plus 6, which gives me an answer of 2. I also could have done that third part by putting the 4 into each of my functions and then subtracting my two answers. So if I would put a 4 up here, 3 times 4 is 12, 12 plus 6 is 18. If I put a 4 in for that x, 4 times 4 is 16. And then if I take s minus t, 18 minus 16, hey, I get the same answer too. So either way works when you're doing that evaluation. So number 2, first part we're going to do is s plus t of x. So if I take my s, that's the x cubed, plus my t, that's 3x squared. Wants me to add those two things, but they're not like terms, so I really can't add them. So I'm just going to have x cubed plus 3x squared. There's nothing I can do with that to simplify it. And then they have s minus t. So I'm going to take the x cubed, I'm going to subtract my 3x squared, and again, since they're not like terms, I'm just going to get x cubed minus 3x squared. And then I'm going to take s times t of negative 1. So if I do s times t, I'm going to take x cubed times 3x squared. So 1x cubed times 3x to the second would give me 3x to the 5th power. Evaluating that at negative 1, 3 times negative 1 to the 5th power. Negative 1 to the 5th power is still negative 1, and negative 1 times 3 would be negative 3 for my answer. On the third one, if I take s times t, x plus 5 times 2x squared, I would end up with 2x cubed plus 10x squared. Not much else I can do with that. And if I do x plus 5 plus 2x squared, not really a whole lot I could do with that other than I could put it in the best order. Not that you have to. 2x squared plus x plus 5, right? Since I don't have any like terms that I can combine. and then we're going to do our subtraction. So again, on that one with the subtraction, I don't really have any like terms. I'm going to have negative 2x squared plus x plus 5, but then I want to evaluate it at 4. So I need to take negative 2 times 4 squared plus 4 plus 5. 4 squared is 16 times negative 2. Negative 32. I'll add the 4 and the 5 first just because I can. Negative 32 plus 9 would give me negative 23. Now that one might actually have been shorter just to put the 4 in up here and subtract. Be careful on the subtraction ones if you do have a binomial or a trinomial that you use your distributive property and change all of your signs. We only had monomials, so we didn't have to worry about it.